Hello student, in this video, we will take a look at the kinematics equation derivation. So firstly, we're going to be using the definition of average acceleration, which is the change of the velocity over the time interval. The change of the velocity is going to be v final minus with v initial over t final minus with t initial. And then for simplification purpose, I will eliminate t initial, or together we can assume that t initial is 0 second. So now we have a more simplified form of the equation, and then I'm going to bring t to the other side. So it will be at is equal to Vf minus Vi. So if I were to bring Vi to the other side, it is going to change in its sign and it will be positive. So if we rearrange the formula, we're going to obtain the first kinematics equation, which is V final is equal to V initial plus with At. Moving on now, in order to obtain this kinematics equation, it is based from two definitions of average velocity. To find average of the velocity, it is going to be Vi plus Vf divided by 2. Moving on, the average velocity is also equal to x final minus with x initial over t final minus with t initial. This is based from the definition of average velocity, and then for simplification purpose again, t initial is going to be equal to 0. So I'm going to substitute this formula into our first formula, and then as you can see, we can rearrange the formula. So I'm going to multiply t to the other side, and then it is going to be equal to this formula. And afterward, I'm going to bring x initial to the other side, and then it is also going to be positive. It is changing in its sign from negative to positive because it's changed side. Alright, so in the end, x final is equal to x initial plus with half Vi plus Vf multiplied with t. For this one, we're going to be deriving the formula of Vf squared is equal to Vi squared plus with 2a x final minus with x initial. So it is based from two formulas that we have used before, which is the first one is Vf is equal to Vi plus with At, and another one is the definition of average velocity. So for the first equation here, I'm going to rearrange the formula, and then it is going to be in the form of t is equal to Vf minus Vi over A. Moving on to the other side, again, I'm going to substitute the average velocity to the other definition, which is Vi plus Vf over 2, and then it is equal to x final minus with x initial over t. So I'm going to rearrange the formula. So what happened here is actually 2 will be multiplied to x final minus with x initial, and the time is going to be moved to the left hand side, will be multiplication, and then Vi plus Vf, we bring it to the other side, it will be division. Now we can substitute the two times together, and then we're going to have this equation. Afterward, I'm going to cross multiply this expression. So what you're going to be seeing is a multiply with 2 multiply with x final minus with x initial. We're going to have this form, and then I'm going to multiply Vf minus Vi multiply with Vi plus with Vf. So this one, you have to multiply one by one. We have here Vf multiply with Vi, which is going to give us Vf Vi. And then Vf multiply with Vf, it is going to be Vf square. So now we're going to be using the second one here, which is negative Vi multiply with Vi, it is going to be negative Vi square. So negative Vi multiply with positive Vf, we're going to have negative Vif. So we can eliminate Vf Vi because this one is positive and then this one will be negative. So the formula is going to be reduced to just this equation, And I'm going to rearrange vi to the other side, so it will be positive. So in the end, we're going to obtain the final kinematics equation, which is vf squared is equal to vi squared plus with 2a x final minus with x initial. So it is always important to remember that the five kinematics equation here are based from the definition of the terms used in kinematics. For example, we have the displacement, the distance, speed, velocity, as well as acceleration. So from those definition, we can derive these five kinematics equation. Remember that in order to solve any problems related to kinematics, sometimes you have to use more than one equation to solve a question. To use the kinematics equation, remember to substitute not only the magnitude or the value as well as its direction. So it can be positive or negative depending on the direction of the parameter. For example, if the acceleration is downward direction, a should be negative value.